Blue Origin just shocked the industry. Days after their flawless NG-2 flight and booster landing, they announced massive New Glenn upgrades starting with Mission 3. The numbers are staggering. Thrust jumping to 4.5 million pounds, payload capacity leaping from 45 to over 70 tons. What's behind this dramatic performance leap? Subcooled propellants in a super heavy 9x4 variant with 9 engines. Can this really threaten SpaceX's heavy lift dominance? Welcome to Space Update 24 Hours. Let's dive right in. Let's talk about what's actually happening under the hood. New Glenn's first stage runs on 7 BE-4 engines, burning methane and liquid oxygen. When Blue Origin first designed these beasts, each engine was rated at 550,000 pounds of thrust at sea level. Do the math. That's roughly 3.85 million pounds total at liftoff. Respectable, but nothing revolutionary. Then testing began. Engineers pushed these engines harder, tweaking parameters, optimizing flow rates. Single BE-4s started hitting 625,000 pounds under normal propellant temperatures. Blue Origin now says they'll reach 640,000 pounds per engine by the end of 2025. But here's where it gets interesting. What if you could boost performance without touching the engine hardware at all? Enter subcooling. This technique chills liquid methane and liquid oxygen way below their normal boiling points, packing significantly more propellant mass into the same tank volume. The denser fuel flows faster through turbopumps and nozzles, generating more thrust from identical engines. With subcooling fully implemented, New Glenn's first stage will produce 4.5 million pounds of thrust. That's 19,928 kilonewtons, a 17% power increase without adding a single engine or making the rocket physically larger. How much does that change the game? Most people focus on first stage power, but the real performance multiplier happens upstairs. New Glenn's second stage flies with 2 BE-3U engines running on liquid hydrogen and liquid oxygen. The original spec called for about 160,000 pounds of thrust per engine, 320,000 pounds combined in vacuum conditions. Testing revealed something unexpected. Single BE-3U engines were already producing over 211,000 pounds of thrust. Now apply subcooling to hydrogen and oxygen propellants, which is especially effective on hydrogen due to its extremely low density. The result? The upper stage will progressively step up to 400,000 pounds of thrust across the next few missions. That's a 25% increase on the stage that actually delivers payloads to orbit. Think about what that means. More energy for high orbits. Direct geostationary transfer orbit injections without spacecraft needing their own propulsion burns. Lunar trajectories. Deep space missions. The second stage upgrade might be even more valuable than the first stage boost. Are customers realizing they're getting this extra performance for free on existing contracts? Blue Origin isn't just tweaking thrust numbers. They're overhauling the entire vehicle system, and the changes reveal their long-term strategy. First, there's a new lower-cost tank design engineered specifically to handle colder, denser propellants without structural issues. Manufacturing costs drop while performance capability increases. That's the kind of win that makes accountants and engineers both happy. The thermal protection system got a complete upgrade too. The reusable first stage now features higher performance materials that survive re-entry heating better and require less refurbishment time between flights. This isn't just about durability, it's about launch cadence. If you can turn around a booster in days instead of weeks, you can fly more missions with fewer vehicles. Avionics receive refinements for better redundancy and processing speed. Recovery operations for both the booster and payload fairings are being streamlined. Speaking of fairings, Blue Origin is finally introducing reusable 7-meter composite fairings. They'll be caught or recovered at sea and flown again, slashing recurring costs and supporting high launch rates for mega constellations like Project Kuiper. All these upgrades start rolling out with NG-3. Every customer already on the manifest, NASA, Department of Defense, commercial satellite operators, gets enhanced performance on contracts they signed before these improvements existed. But the announcement that really turned heads came next. Blue Origin's roadmap slide showed something nobody expected this soon: New Glenn 9x4. The name tells you everything. 9 BE-4 engines on the first stage, 4 BE-3U engines on a stretched second stage. Same subcooled propellant technology, same reusability with booster recovery, just significantly bigger. The performance numbers are staggering. Over 70 metric tons to low Earth orbit, more than 14 metric tons direct to geosynchronous orbit, over 20 metric tons on trans-lunar injection trajectories. To accommodate larger payloads, the 9x4 gets an 8.7-meter diameter fairing, wider than the standard version and competitive with the biggest payload envelopes flying. Blue Origin says both configurations will operate simultaneously. The upgraded 7x2 for most missions where 50-plus tons to LEO is sufficient, and the 9x4 when customers absolutely need maximum throw mass for oversized satellites or massive lunar landers. Here's what makes this remarkable. Blue Origin achieved their first orbital flight in January 2025. Their second flight just happened days ago with a perfect booster landing. They're not even a year into orbital operations, yet they're already announcing a super heavy variant and systematic performance upgrades. What timeline is this company actually operating on? The timing couldn't be more strategic. The heavy lift launch market is exploding right now. Amazon needs hundreds of Kuiper satellites in orbit yesterday. The Space Force is building resilient satellite architectures requiring diverse launch providers. NASA has Artemis lunar payloads stacking up in processing facilities. Everyone wants direct injection capability to save spacecraft propellant and extend mission life. By offering an upgraded 7x2 configuration, pushing past 50 tons reusable to LEO, Blue Origin didn't give exact numbers, but the thrust increase implies it's well above the original 45-ton specification, plus an optional 70-plus ton monster. They're covering virtually every mission profile short of full Starship-class capabilities. SpaceX has dominated heavy lift through Falcon Heavy and is developing Starship for super heavy missions. ULA's Vulcan is capable but expensive. China's Long March family serves primarily government missions. New Glenn with these upgrade slots into a market segment that's been desperately underserved. High performance, high cadence, commercially competitive heavy lift with full reusability. Subcooling isn't new technology. SpaceX has used deep cryogenic propellant densification on Falcon 9 for years. It's a major reason Falcon 9 delivers more performance than its dimensions suggest. But applying subcooling at this scale to both methane/oxygen and hydrogen/oxygen stages on the same vehicle represents serious engineering execution. The first two New Glenn flights used original thrust levels and non-subcooled propellants. Both performed flawlessly. These upgrades are essentially free performance gains from propellant densification and hardware maturation. No major vehicle redesign required, no years-long development program, just systematic optimization of existing systems. The render Blue Origin released shows New Glenn climbing into the night sky. Upgraded exhaust plumes noticeably brighter and more intense. The American flag on the interstage illuminated by moonlight. Same clean design language, just more powerful. And since these changes begin with NG3, we're probably only months away from seeing the subcooled booster ignite for real. This announcement marks Blue Origin's transition from finally flying mode to rapid iteration and scaling mode. They have multiple vehicles in production, a manifest packed for years ahead, and now a clear two-variant family approach sharing common technology. The fact they are already implementing reusable fairings and advanced thermal protection shows they're thinking seriously about flight rate and cost reduction, not just achieving initial success. Going from 0 orbital flights in 2024 to 2 perfect missions in 2025 with textbook booster landings, then immediately announcing 4.5 million pounds of thrust plus a 70-ton variant before the year ends. That's not incremental progress. That's acceleration. New Glenn isn't just participating in the heavy lift market anymore. It's arriving with capabilities that make it one of the most powerful rockets currently flying. And the 9x4 roadmap shows this is just the beginning. The real question now is execution speed. How quickly can Blue Origin actually implement subcooling operations at Launch Complex 36? How will the new thermal protection system perform on the next recovery? If the past 11 months indicate anything, Blue Origin is moving considerably faster than anyone predicted. So what does all this actually mean? Blue Origin just went from orbital rookie to serious heavy lift contender in less than a year. They're not talking about future plans or concept renders anymore. These upgrades start with Mission 3, possibly launching within months. The numbers speak for themselves. First stage thrust jumping 17% to 4.5 million pounds. Second stage power increasing 25% to 400,000 pounds. Payload capacity leaping from 45 tons to over 70 tons with the 9x4 variant. Reusable fairings cutting costs. Advanced thermal protection enabling faster turnaround. All while maintaining full booster reusability. This is Blue Origin's declaration: we're done catching up. We're here to compete. The space industry just got more interesting. SpaceX built their dominance on reusability and rapid iteration. Blue Origin is now playing that same game with comparable hardware and serious financial backing. The heavy lift market has room for competition, and customers win when multiple capable providers exist. Will Blue Origin maintain this momentum? Can they actually deliver NG-3 with subcooling operational? How quickly will the 9x4 variant fly? We'll be tracking every development right here on Space Update 24 hours. If this breakdown gave you new perspective on the launch industry, hit that like button. Drop a comment with your thoughts. Is New Glenn now a real SpaceX competitor? Share this with anyone following the space race, and subscribe to Space Update 24 hours so you never miss the next major announcement. The competition for space just intensified. We'll see you in the next one.